Let's now begin by discussing inheritance. Of course, there are heirs to smart contracts. They can have parents. So what do we mean by that? Inheritance in programming is a concept where you can base an object, class, or in our case here, a contract, upon another contract. So we can implement one contract and then implement a second contract that includes all the functionality of the first contract by inheriting from it. So this would be the single case here. But inheritance actually works also with multiple contracts. And you can have multi-level, hierarchical, multiple, or hybrid inheritance. So you can see we can inherit from multiple contracts as shown here. We can inherit from a contract in multiple other contracts as shown here. And we can even inherit from multiple contracts that have the same underlying base contract as shown here. In the hybrid case here, of course, it doesn't mean we now have the functionality of contract D twice in contract A. Functionality can, of course, only exist once. But what exactly do we mean by functionality? Well, we mean all its public, external, or internal state variables and functions. And now you know where the internal definition is used for. If you remember, we had this here. That's the difference between private and internal. Private function can only be used in the contract itself, but internal may also be used for any contract that inherits from that one. And the result of inheritance of contracts is always just one single contract. So Solidity combines all the functions and state into a single contract. So we could also just write it all in one contract, basically. Inheritance is only a tool for writing better code by avoiding duplicated code and organizing it. So, how do we write all this in code? It's quite simple, really. When we define a contract, we just list all inherited contracts with the is keyword. So, for single inheritance, this is just contract A is B. And for multiple contracts, as is the case for hierarchical inheritance, for example, where you have multiple base contracts, we can just list the inherited contracts next to each other. So here it's contract A is B, C. There are some more complicated cases to consider when you have complex inheritance structures, but it's not very common. For example, sometimes you might get an error when compiling that says something about L3 linearization. Then you just have to change the order of the inherited contracts, so here. And generally speaking, by listing contracts first that are inheriting less and contracts that inherit a lot, you list last. Or, if that didn't all make sense to you, just play around with the order when inheriting it compiled successfully. And you should know that you cannot have visible state variables with the same name in derived contracts. Obviously, because otherwise this would create a name clash. You can, however, have functions with the same name. And then which functions are then actually executed will depend on the context. This concept in programming is called polymorphism. Maybe you've heard of it. And always the function in the most derived contract in the inheritance hierarchy will be executed. But you also have full control over what to run yourself, because alternatively you can also just call the contract name.function name or super.function name. And one special consideration is if a constructor from a base class takes an argument, it needs to be provided in the header. So here you can see if we inherit, for example, from our ERC20 contract and create a new constructor, then we have to call the ERC20 constructor in the header with the parameters for the ERC20 constructor. And to make less mistakes about this polymorphism aspect in Solidity, whenever you want to override a function in a derived contract, you have to specifically allow this. So here, let's say we have a base contract and a derived contract, and you can see we both have my function. So the question would be which function then is executed in the derived contract, because you have two implementations. And the answer in this case is it would be the most derived contracts function, so from the one here. And if you want to do this, then base functions can be overridden by inheriting contracts to change their behavior if they are marked as virtual. So my function in the base contract here needs to be virtual. And the overriding function must then use the override keyword. So here, override and then base contract. You can also declare a contract as abstract, as shown here, if you don't need to actually deploy the contract on its own. This is useful when a contract is only meant to be a base class, but not used by itself. And because it cannot be deployed, we have to create a new contract that derives from this one at some point. You can also declare functions that don't have any implementation because of this, but any such non-implemented functions need to be implemented in the derived contract later. Or alternatively, you can also just use interfaces. Interfaces are similar to abstract contracts, but they cannot have any functions that are implemented. So then why would anyone use them? Well, they are particularly useful for interacting with common types of contracts. For example, here we have an interface for the ERC20 standard, and you are declared with the interface keyword, and usually you prefix the interface name with a capital I to clearly indicate that this is actually not a contract but an interface. Now, it doesn't really matter how this contract here is implemented under the hood. If you only want to call the standard functions like approve or transfer. So this is useful when you then just want to interact with some address contract. And then if you're using someone else's smart contract in your own contract, for example, you're interacting with other people's ERC20 contracts, you don't know how they are actually implemented in detail, but it doesn't matter because presumably they are all following the ERC20 standard, and then you can use an ERC20 interface to actually interact with any other ERC20 contract.